This here's the Excel spreadsheet that my granddad and I used to calculate the altitude of the model rocket with the different masses. The first things on here are the basic information, which is what I'll call my variables. Using air drag as an example, you can see that we use a coefficient of drag and air density and also the acceleration to get the total air drag in newtons. First off, you have the thrust in newtons, which we were able to calculate using a thrust curve sheet that we got with the model rocket engine. We're able to take that and divide it into the time steps of 25 thousandths of a second. And after you divide that up, you can find out how many newtons are used in each time step. Next, you have the air drag, which is just the air resistance exerted on the rocket. Next, you have the impulse of the actual rocket engine. This is the actual mass of fuel that is used in the whole launching process. And the total propellant weight or mass is 3.78 grams. And after all of the rocket propellant is burned up, the rocket should have lost weight, and it should end up as and the rocket should weigh 27.2 grams, about that. And you have to make sure that's all calculated into the spreadsheet because it loses weight as it launches. This right here is basically all of the forces exerted on the rocket. Because first of all, you have thrust, which is the rocket engine pushing up on the rocket. You have weight pushing down on the rocket, which is gravity. And you have drag pushing against the rocket as it tries to move up, and that's air resistance. You have the acceleration at the end of the time step, which is in meters per second squared. You have the velocity at the end of the time step, which is in meters per second. And then you have the distance traveled, which is in meters. After a few months of working out the kinks and getting this to work, you can scroll all the way down here where I've marked the peak, or the apex of the flight. You can see that it's around 230 meters in the air. Now, if you've looked at my project, you would know that all of this right here was actually incorrect. It was way off, based on my results and the conclusion. The problem was, this wasn't the only thing that went wrong in the project. Our rocket altitude measuring techniques may have been skewed up a bit, and those could have also been wrong. But let's hypothetically say that those were correct, and that this was 100 meters off, too high. This whole spreadsheet still demonstrates a very valid thought process that I've had to go through with some assistance from my granddad. I looked in some pretty much some rocket science textbooks, trying to figure out some coefficient of drag stuff, and it was very difficult. And I think that it really shows me like what it's like to be a rocket scientist and what a future in this job would be like. I'm really excited, and I think it'd be pretty cool. What I'm doing right now could tremendously help me do stuff in school or like in college, because with an Excel spreadsheet, it's like a whole formula. It's like a calculator almost. I can come up here and change stuff. Let's say change the weight to 41 grams and change that. Once you press enter, you can scroll down to the bottom, look at your new height. You can see it's around 161 meters. But put all that aside. My whole project right here is basically proving Newton's laws. So if you say that his second law, F equals ma, because with a greater mass there comes less acceleration. With a greater mass of 41, I was able to calculate that with the greater mass of 41 grams, it had less acceleration and it didn't go nearly as high. Legitimately, I just proved Newton's laws with a spreadsheet.